Voyager 1. Humanity's greatest journey begins. Voyager 1. Humanity's message from the edge of space far beyond the Moon, the planets, and even Pluto. There exists a small but mighty piece of human engineering. It's not flashy. It doesn't carry passengers or advanced artificial intelligence. Yet it holds a title no other machine has earned. The farthest human-made object in history, NASA's Voyager 1. Launched in the summer of 1977, Voyager 1 has now traveled more than 14 billion kilometers from Earth. It has left behind the warmth of our sun and entered a dark, distant region known as interstellar space. A place where the stars no longer twinkle in familiar patterns and where the influence of our solar system begins to fade. Here, Voyager sails through a sea of cosmic energy, surrounded by invisible forces we are only beginning to understand. Even more astonishing is that this spacecraft, older than most of the technologies we now take for granted, still talks to us. Using radio signals powered by a 20-watt transmitter, the equivalent of a kitchen light bulb, Voyager 1 sends back data collected by instruments designed over 5 decades ago. It's like asking a rotary phone to send texts from the edge of the galaxy, and somehow, it does. Voyager 1 continues to surprise the world, not just because it's still active, but because it's still discovering, still revealing secrets from the deep unknown. So what exactly has this remarkable spacecraft found out there? Why is it still important to science, even after more than 45 years? A rare cosmic alignment. The birth of Voyager. The Voyager mission began long before the rockets were fired. In the early 1970s, a NASA engineer named Gary Flandreau, working at the Jet Propulsion Laboratory, made a groundbreaking discovery. He realized that once every 176 years, the outer planets, Jupiter, Saturn, Uranus, and Neptune, align in a special way. This rare configuration would allow a spacecraft to slingshot from one planet to the next, using their gravitational pull to gain speed, a maneuver known as gravity assist. This cosmic shortcut would dramatically reduce travel time. Instead of taking 30 years to reach Neptune using traditional propulsion, a spacecraft could get there in just 12 years, saving fuel, money, and precious time. NASA knew it had to act fast. This planetary alignment wouldn't come again for nearly 2 centuries. So, in August and September of 1977, it launched 2 identical spacecraft, Voyager 1 and Voyager 2, just 15 days apart. Originally, the Voyagers were intended for a short, focused mission, a 4-year tour of Jupiter and Saturn. But no one could have predicted the journey that lay ahead. Against all odds, they far outlasted their expected lifespans and became explorers of the outer planets, the heliosphere, and eventually, interstellar space. Opening the door to the outer planets, Voyager 1 and its twin opened humanity's eyes to the mysterious gas giants. They delivered the first close-up images of Jupiter's raging storms, including the Great Red Spot, a hurricane larger than Earth. They revealed Saturn's intricate ring system and confirmed its composition of icy particles and dust. Perhaps most surprising was the discovery of volcanoes on Io, one of Jupiter's moons. The first time active volcanic activity was seen on another world. These spacecraft turned abstract, textbook planets into real, living worlds with motion, chemistry, and complexity. They made the outer solar system feel not just distant but alive. Voyager 2 went even further, making the first and only close passes of Uranus in 1986 and Neptune in 1989. It revealed magnetic fields tipped at strange angles, bizarre rains, and mysterious dark storms on Neptune that scientists had never imagined. These encounters brought light to worlds that had been, until then, mere points of light in the night sky. Built to last against all odds. Despite being built in the 1970s, the Voyagers were marvels of engineering. Each spacecraft is about the size of a Volkswagen Beetle, powered by plutonium-based generators that convert heat into electricity. They carried just 69 kilobytes of memory, barely enough to hold a modern text file, and stored their data on magnetic tape recorders. Yet they managed to travel through the asteroid belt, survive intense radiation near Jupiter, and endure the freezing emptiness of deep space. Their onboard instruments collected everything from magnetic field readings to plasma wave data, all transmitted back to Earth through massive deep space network antennas. Voyager's journey was never just about collecting data, it was about changing perspective. It redefined how we view our solar system, our galaxy, and even our place in Voyager 1, into the unknown, crossing the final frontier after decades of travel. Voyager 1 reached what scientists had long considered the boundary of our solar system, the heliopause. This invisible border is where the solar wind, the stream of charged particles flowing from our sun, meets the colder, denser forces of interstellar space. On August 25, 2012, Voyager 1 made history. It crossed the heliopause and officially became the first human-made object to enter interstellar space, a realm untouched by any machine or person before. It was a moment of immense pride and awe for humanity. We had launched a probe in the 1970s that was now sailing through the cosmic ocean between the stars. But this crossing didn't happen exactly as scientists expected. Many anticipated a sudden, dramatic spike in cosmic radiation, and a noticeable shift in the magnetic field direction, something that would clearly signal Voyager's transition. Instead, the change was far more gradual. Cosmic ray levels did rise, but the magnetic field barely shifted. This sparked fresh questions. Was the heliopause not a sharp edge, but a fuzzy, shifting region that changes with time? Could the Sun's magnetic field be strangely aligned with the galactic field? Was Voyager telling us that the boundary between star systems isn't a wall, but a seamless blend? These surprises weren't disappointments, they were breakthroughs. They revealed that the edge of our solar system was more mysterious and complex than we had imagined. It wasn't just a finish line, it was a gateway to the unknown. Interstellar discoveries. A new cosmic map. As Voyager 1 pushed deeper into interstellar space, it continued to send back vital data using its aging but reliable instruments. Its sensors began to detect plasma waves, showing that space, far from being a cold, dead vacuum, is filled with pockets of charged gas, with varying densities and energies. These fluctuations weren't random. They were the fingerprints of ancient events, possibly the aftershocks of long-dead supernovae, the explosions of stars that ended their lives millions of years ago. Each measurement offered a clue to the evolution of our galaxy, and how matter, energy, and magnetic fields have shaped it over time. Voyager showed us that the space between stars, once thought to be silent and empty, is actually dynamic and alive. It's a place where magnetic fields twist and dance, where plasma clouds drift like ghosts, and where the legacy of the universe's oldest events still echo today. And all of this was discovered by a spacecraft built in the 1970s, powered by technology older than most of today's scientific calculators. A small machine with a giant legacy now more than 14 billion kilometers away from home. Voyager 1 continues its mission, a lonely traveler sending whispers from the edge of the galaxy. Its signal, incredibly faint, takes over 22 hours to reach Earth, traveling at the speed of light. And yet, we still hear it. Every beep, every pulse, is a message from a place no human has ever seen. Its radioisotope power source is slowly weakening. Its systems grow older by the day. But Voyager is still alive. Still working. Still making history. This mission has become more than just a collection of data. It's a testament to human ingenuity, perseverance, and vision. Voyager proves that even the simplest of tools, if built with care and purpose, can achieve the extraordinary. A symbol of human spirit, Voyager 1 is more than a scientific success. It has become a symbol of human curiosity, ambition, and courage. Launched before personal computers, before the internet, before smartphones, Voyager now floats in deep space, alone, yet still connected to us. It reminds us that our thirst for discovery can carry us farther than we ever dreamed. That we can reach across billions of kilometers and still learn something new, something powerful. The spacecraft carries with it a golden record, a time capsule of Earth's sounds, images, and greetings in 55 languages. It's a message for anyone, or anything, that might one day find it. A cosmic bottle cast into the vast ocean of space, carrying our hopes and stories. Someday, Voyager will go silent. Its systems will shut down. Its voice will fade. But its legacy will never disappear. It will continue to drift, perhaps for billions of years, a silent ambassador of Earth, sailing endlessly among the stars. And as long as it does, Voyager 1 will remind us of who we are: explorers, dreamers, creators of machines.